just has some of the representative elements. Remember, representatives are 1A through 7A. Why do we use the representatives so much? Is because they're so predictable. And so we have the 1A through the 7A. Okay, if we look at 1, 2, and 3A, remember how they tend to become cations? And what they have here in green, they're showing you the relative size of the neutral. And then they have its own cation, what we were just looking at before. And the cation, which is in blue here, or purple, is always the smaller of the two. Because remember, with the cations, you've lost electrons, you've lost an entire energy level. Almost always. Especially, it is true for the representatives. You've lost an entire major level. Okay, then we come over to this side where we have 5, 6, and 7A. Remember, the guys up here tend to become anions. Those are the nonmetals. And they're showing you, when it's neutral, it's green. So they kept the same color code they did over here. But when you picked up, in this case, you picked up 3 electrons. Lots of repulsion. It's going to spread out. 3 tomcats in the room. Okay, well, then my analogy falls apart. If there's 1 tomcat in a room, who's he got to spread out from? But here we are with oxygen at -2, and the red here represents the size of the anion. And so the 2 generalizations are right here, because you're not going to have benefit of that on test day. Okay, then the third possibility, compare any group of ions. Okay, when we attack that, we really don't have a generalization. What we have to look at is we look first at the electron configuration, and then if that doesn't work, we play the numbers game. So remember, with ions, 2 attacks, ions. First we look at electron configuration, then we look at the numbers game. Only if the electron configuration fails you. Okay, so let me give you a big list here. And let's see what we can do with it, and no fair looking up there. Okay, let's say I have fluoride -1. I have sodium +1. I have oxygen -2. I have magnesium +2. Let's see. I've got oxygen. Whoops, I got it already, don't I? I've got nitrogen -3. And whoops. And I've got, let's see, what else shall I have? Aluminum at +3. So I've got 6 ions, and we want to rank them. Smallest to largest. Okay, so let me just rewrite these. And let's try the electron configuration of each. So I've got F-1, sodium, oxygen, magnesium, nitrogen, and aluminum. So, what was our first line of defense? What shall we do first? Electron configuration. Okay, Emily, do this one for us real quick.
1s2, 2s2, 2p5. 6.
2p6, because it's ganglia. You were doing the neutral, but I want the anion. Okay, time to hit this one for me.
I don't know how, it's not here that day we did.
Oh, okay, okay. Okay, don't give the show away.
The light bulb just
You
went
know
off, so.
too much. You guys didn't hear that. Put it out of your memory tapes there. Okay, let's do this exercise, all right? Russell, hit it. What's this one?
1s2, 2s2, 2p6.
Okay, I want oxygen -2. Marco, hit it.
1s2, sorry, 2s2, 2p6.
Okay, Eddie, tell me what magnesium +2.
So 1s2, 2s2, and 2p6.
Yeah. You see a trend coming here that Bruce saw 2 minutes ago? Okay, I want nitrogen -3. Alex, hit it.
1s2 to 2s2 to 2p6.
Yeah. Aluminum +3. Nikki in the third row.
1s2, 2s2 to 2p6.
Okay. So I could say these are all what with each other? Isoelectronic. Okay, the electron configuration just failed us. And if you'd all been as clever as Bruce, you would go, oh, they've all got the same electron configuration. You would have said that early on. Well, that means we got to play the number game. And so for each one of these, protons, electrons, protons, electrons, protons, electrons. Why don't I mess around with neutrons again? Why don't I care about neutrons? They don't have a charge. They're not going to have anything to do with the attraction part. They contribute mass, end of story. Okay, let's just fire down. We've covered some of these before, but let's just fire through. And of course, you need atomic numbers. Let's see, 12, 7, and this one is 13. Okay, let's fire through here. Eddie, tell me about this one, protons and electrons.
9 protons and 10 electrons.
Okay, all right. Jeanette, how about this next one?
11, 12, 6.
Count them. See, if you're +1, you would have 11 if you were neutral. But we are not neutral. So how many do we have?
10.
10. Okay, let's do oxygen here. Antonio, what is it?
8 and 10.
Good. Magnesium, right here. Steve, can you do it?
12 and 10.
Good, good, good. Charles, can you do it?
7,
Uh-huh.
10.
10. Okay. And on our last one, right here, Meredith?
13.
Okay. And of course the premise is, whoever can attract best. Now see how I've changed the tables on you just a little bit from those last ones we looked at? The last one, we were talking about if you have more electrons, but you got the same number of protons, what happens? Now we're looking at, we got the same number of electrons each time. I think in some ways this is the easier of the two ways to go. We got the same number of electrons every time because they're isoelectronic with each other, but we've got more positive charge. And you know if you got more positive charge, it's going to suck them in. So, if you crack the code, Bruce, who's the smallest of them all?
Mike.
7.
Okay, it's got +7. Okay, does everybody agree with that?
The other way, is it aluminum?
Yeah,
It's aluminum.
Oh.
it's aluminum.
Okay.
Okay? Got a choice. You met 2 new women. Forget about the fact you have a wife.
Okay.
One has $7 million and one has $13 million.
Oh, easy. Okay.
Easy
Gotcha.
choice. Okay? So, aluminum is going to be the smallest because it tracks best.
Gotcha.
Now see, once we crack the code, see it's sitting there with 13. Fake money.
Is this aluminum, I'm sorry, is this the electronegativity?
No, this is size. We're doing size.
Oh,
We're in section 5.
okay.
We're size. Okay, when you talk electronegativity, you're always talking just neutral atoms. That was back in the previous one where we had the arrow system and the whole shebang. This is ions. Okay, we just used that guy. Who comes in next? Kashan? Magnesium. Okay, so we just used that one. Who's next, Eddie?
Sodium.
Sodium. Actually, sodium ion. If you were doing Al stuff, you'd have to write the term ion or they'd count it wrong. So that's our next one. Russell, who's next?
Chlorine.
Okay, fluoride when it's negative. Okay, Brittany, who's next?
The oxygen.
Okay, and then the only one that's still there, nitrogen. Okay, so it's a game of attraction.
I have a question for the test, like they would all be like that one, like they all end on the same.
Not necessarily, it could be a tasteful combination because we could throw, let's see, you could have this whole series, but you could have that one just tossed in. Look where bromide is. Okay, it's clear down there in the fourth period. You're in energy levels. You can think electron configuration. If you did the electron configuration of this, can I be lazy and just put krypton, right? Whereas these guys are all neon. Okay, so what Brittany asked, she said, if you have another question to do, are they always going to work out to be isoelectronic? No. I mean, you could have, and what I did to fix up a question that could be similar, what if you had this rundown, plus they tossed in bromide? Easy call. Because if you're thinking bromide, here, you're way out here. You're on the, let's see, we just filled 4s2 and then 3d10, 4p6. You're on the fourth. So even though it's only -1, you're going to be the biggest of them all. So you can think, see, electron configuration would have told you what to do with bromide, but the rest of them, you'd have to play the numbers game. Nina?
I don't understand. How did you rank them based on the protons and electrons?
Okay. Okay, we're thinking, what guy do we want? And we are a gold digger. We only worry about money. Who will we be most attracted to? This guy has 13 million. That guy only has 7 million. That guy has 12 million. I mean, if somebody had 12 million or 13, I mean, I wouldn't care. I'd take either one of them. But if we really care about money, most attraction makes you smallest. You want to get in really close to that guy.
So you're talking, okay, it's still again the attraction to the protons.
Attraction. Yeah, protons and electrons.